Okay, so based on function dependency, we can define the keys in this page. What is a key for a relation? So generally, given a relation as well as a set with a set of attributes, we can say if a bunch of attributes can function determines all the attributes of a relation, and none of its subset can determine all the attributes in the relation. If so, then we can say this bunch of attributes will be the key for the relation. The first condition we have here is the function determines all attributes of the relation. And the second one is none of its subset determines all attributes of the relation. So here we need to pay attention to the second condition. We never say the key should be the smallest size, right? We just say none of its subset can determine all attributes of the relation. So what does this mean? We can provide you with an example to illustrate this definition and why we highlight the second condition. Let's assume, for example, we can change the font first, we can change to 50. Let's assume given a relation R is a man, and this relation has 5 attributes, A, B, C, D, E. If we have function dependencies, the first one we have is A, B implies A, B, C, D, E. We have a comma here. Given 2 attributes A, B, they can imply all attributes of C, D, E. At the same time, we can get A cannot imply A, B, C, D, E. We just write A, B, C, D, E for short. Or let me copy this, to make sure you can follow this example. We say A cannot imply all the attributes, and B cannot imply all the attributes. We just add one cross line to this implies denotes it cannot implies. We also have B cannot implies all the attributes as well. And this is one case. Let's assume we have another case. C, D, E can implies all attributes. And CD cannot implies all attributes. CD cannot neither. Let me write them down in a computed way so you can follow this example. CE cannot either. And DE cannot neither. I can use a night column for them. They are not very important, right? I can use a night column for them. Okay, so this is a relation as well as FD we can get. And the question is, what is the key for the relation based on the given FDs? FD denotes function dependency, right? What's the key for the relation? So for the first one, we can say AB implies all the attributes. A cannot, B cannot. It means none of the AB subset can implies all the attributes. Therefore, AB will be a key, right? Based on 1, we can derive A, B is a key, right? For R. Now how about CDE? According to the second FD, so we can get CDE implies all the attributes in the relation. None of its subset, CD cannot, CE cannot, DE cannot. It is not easy to derive that C cannot, right? Because CD cannot, it is easy to derive that C cannot implies, right? Otherwise, CD should be able to derive all the attributes. We can also get D cannot, right? And E cannot. We didn't show them here because they can be derived from this more complex FTs. We can just remove one from here. We can derive C cannot, D cannot, E cannot. So based on this second FTs, we can derive CDE is also key, right? Based on second condition, based on the second FTs, we can get CDE is also a key for. Then the question, which one is correct? AB is or CDE is? So to answer this question, we need to follow the definition. According to the definition, we have two requirements. The first requirement is they can functionally determine all the attributes in the relation, and none of its subsets determines all the attributes. Therefore, by following this definition, both AB and CDE, they are the keys for the relation, even though AB is much smaller than CDE, right? Because AB is set, we only have two attributes, right? However, CDE we have three attributes. But according to the definition, both of them are the keys for the relation. So therefore, if we want to decide which one is the key for a relation, we can not only see the size, how large this set is. This set size is 2, however, this one is 3. However, according to our definition, both of them should be the key, right, for the relation. So by following the definition of the keys, we will be able to define the keys for the relation. Okay, this is the key. Now what is the super key? If we have a set of attributes which contains a key, then this set of attributes will be a super key. Right. Let's come back to the example. We have derived AB is the key for the relation, CDE is a key for the relation. Then we can also get some other attributes. We can also get some other attribute set that A, B, C is a super key, right? For because ABC contains AB, right? AB is the key, then ABC is the super key. Similar will for C, D, E. We can also add one more attribute that B is also super key for the relation, right? Then we can further derive a larger super key that A, B, C, D, E is also super key for the relation, right? Because it contains a key AB, or it also contains a CD as a key, right? So they are all the super key for the relation. This is the largest one we can get. It covers all the attributes already, right? So you can differentiate the definition for keys, how to derive them, and what the definition for super keys. We have been using the keys and super keys for a long time. Here we provide a formal definition based on the FTs. Okay, let's come back to the slides. Normally we need to know the keys for the relation in our database schema as well as relations, so we can refine the schema based on the rules and algorithms to be introduced later. The keys is very important. Then the question will be, how can we find the keys? Before we provide you with some rules to define the keys for a relation, right? It is based on some heuristics. When we are doing a translation from the ER diagram into relations, we let you know we can get the keys, right? If we translate an entity, a rectangle into a relation, then the key of the relation is a set of attributes, which is the key for the entity set. When it comes to the relationship, if we are doing a translation of the many-to-many relationship, then the key of the relation includes a set of all the attributes which are the keys in the relations corresponding to the entities. we combine the keys from these corresponding entities together to define the key for the many-to-many relationship. As to the many-to-one relationship, or one-to-one, as well as the working set and multi-way relationships, we can also have some rules provided before, right? They are all based on some heuristics. So these are the heuristic rules we derive from the previous sections. And next, let me show you how to derive the keys based on FDs.